When you say intelligence, do you see that it's only one kind of intelligence we talk about? It is in this context, we actually have three kinds of intelligence. Let me talk to you from the bottom. We all have heard of horror stories from Elon Musk saying that there is a danger to humanity by all these crazy robots taking over the world, or some super intelligent machines powered by super intelligent software taking over the humans, maybe causing chaos, maybe causing harm, physical harm. Or all of you have seen the movie Robot, right? You see what is being talked about. It's about a doomsday scenario where potentially these machines powered by very powerful software can take over human tasks and do the task better. And not only that, use that to create a world of dominance. But, that is basically about creating what we call as a notion of artificial superintelligence. Artificial superintelligence actually is a potential theoretical possibility. Yes, agreed. But for practitioners in AI, even the best algorithm designers in AI, you talk to them, they will feel this is more a scare than a reality. Possible in limited sense, sometimes it will be good, but humans will always have control. It's not that these are things which are left unleashed and they can go and do. In fact, it is only humans with their evil intentions can turn them into something evil. There are scenarios where that is possible. If there is a possibility that a person with an evil intention wants to use this powerful technology to create an evil act, it's a human-guided evil act. It's not a machine taking over a human act. So artificial superintelligence, where we're talking about AI being much smarter than the best human brains in every field and giving a competition to humans, is kind of on a theory. At least that's my personal belief. Not only mine, talk to many big researchers. Talk to Yoshua Bengio, or talk to Anne Goodfellow, or Jeffrey Hinton, the fathers of AI, McCarthy. They'll all say that this is actually more like rumor mongering or posturing. But then, when it comes to, let's go to the first one. The first one is what we call as artificial narrow intelligence. Artificial narrow intelligence is basically where we are today. We are seeing very smart Jeopardy winning program called Watson, which is very focused for winning Jeopardy. Same way, we have an extremely smart driverless car driving a specific model of Tesla. But these narrow tasks are narrow in the sense that these are programs of AI which are meant to do only specific tasks. Very narrowly specific tasks. You go out and win a game of chess? Yes. You go out and win a game of Go? Yes. You go out and win a game of poker? Yes. You go out and create a cancer diagnosis doctor? Yes. You go out and create a Tesla model car automated driver? Yes. That is where we are. We are talking about defining a very narrow task with a very narrow scope and creating an automated AI program which can take up that and do that single task very well, maybe better than humans. But where does it fail in compared to humans? All of you know in India we do right-hand driving, right? But then when you go to a left-hand country like US, it's a bit change in the habit, right? Driving habit. But what I've seen is a human being does not take more than 3 days to get accustomed to the new road conditions and the traffic signals and start working on his driving skills and readjust to be able to drive in United States. That's human agility. And that, unfortunately, is absent in all the current successful AI programs which are programmed for artificial narrow intelligence. Means a program written for one specific task being reprogrammed to do any slight variation, it requires significant reprogramming. So that is the expectation we feel is called artificial general intelligence, where given a program and a context of a particular application, say a particular game, say Go, you want to go and apply it to chess again, it will reprogram itself without much manual intervention and extra knowledge, extra handcrafted re-engineering of that to be able to work on a new game like chess. Same way, you created a Tesla driverless car program, it will go and get yourself adjusted to tomorrow, Google driverless car. That is the expectation in artificial general intelligence. The idea is, just like a human being looks at the environment around, reasons with it, and adjusts itself based on its background knowledge and the capability, very natural way, the AGI programs would be, instead of confining themselves to one narrow task, they will actually reprogram themselves to carry out general tasks. And that is also called strong AI. But today, we are at least 30, 40 years away from realizing true artificial general intelligence. There are many reasons for that. The reasons is the way we are approaching AI today is very, very narrow problem-specific approaches, which we'll go through in this masterclass. Whereas in the concept of artificial general intelligence, we need to bring what is known as something humans are very good at, which is common sense reasoning. Common sense reasoning means we are always able to change our belief state, change our way of working, depending on the environment. Very naturally. Suppose it's a rainy day, we'll automatically take an umbrella. Suppose it's sunny, we'll automatically not take an umbrella. This is something which comes intuitively. It's not like we have to program these rules explicitly. So, artificial general intelligence is where we start to see tenets of very close to human intelligence is the ultimate goal of AI, which is somewhat far away. But let me tell you, in the latest, game programs developed by the AI community, especially after the first AlphaGo defeat of the Go champion, very recently AlphaGo Zero, which was a very modern version of AlphaGo, was displaying some very strong tenets of some of these elements with zero background knowledge, how to pick up, context of the environment and train itself and become smarter. So it was showing some tenets of artificial general intelligence, but we're seeing them as rare and slowly picking up. I don't think AGI is yet there. So today we are in the realm of ANI. So the goal of any time you talk about a person talking about AI machine learning, ask the person or ask yourself, what is the narrow task you want to do? You have to work towards defining that goal, only then you start working on how you can define the AI system to solve that problem. Defining the problem is the first step in any problem solving. And one of the things, let me tell you for lack of a better data point, but one thing a lot of people in the IT community get criticized is we concentrate a lot on how to do things. Process, program, project. But a lot of time should be spent instead on what. What is the problem being solved? What is the customer problem? First, is there a problem? Then you come back and do your house or all that. So in AI, it's no different. You have to understand what is the narrow task which you need to solve, and then come back and start. It's like, otherwise what happens is you have a big hammer, right, which is AI, and you try to find out where there's a nail where I can hit. That's a wrong approach, right? You have to first find out which is where you need the nail to be put, then go and search for a hammer, go and hit it. So that is very important in AI or any software per se, any IT program per se. But then in AI, it's no different, especially given that we're talking about artificial narrow intelligence, your definition of the task has to be very perfect.